Now, last time we did transformations, we did it for exponential functions, right? Transformations, like what does it actually mean? It means you have some parent function, like for example, this exponential function, we can call it y equals 2 to the power of x. And then we can shift it 1 unit up, right? 1 unit up, boom. And then this equation becomes y equals 2 to the power of x plus 1. You remember that? You can move it left, right, up, down. You can also flip it. You can stretch it. You can compress it. So all the transformations are exactly the same. By that, I mean they all follow this rubric. Y equals a, some function, doesn't matter what the function is. And then you have k x minus d plus c. Now, for example, let's say you have y equals 3 times 4 to the power of 5 x minus 6 plus 7, right? Here, what kind of a function is this? Is it a quadratic? Is it a polynomial? Is it a sine, cosine? What's going on? So if you notice, right, notice the exponent, the unknown is in the exponent, right? The x is in the exponent. So this is an exponential function, okay? This is an exponential function, which has the base function of 4 to the power of x. This is our parent function. Our base is 4. That means our parent function is y equals 4 to the power of x. Now our a is 3, k is 5, d is 6, c is 7. So a3 means it's a vertical stretch. Vertical stretch by 3. k5, what does that mean if you remember? K is 5. It has something to do with the horizontal. Is it a stretch, compression? Is it a reflection, left, right, up, down? It's going to be,
Compression?
yeah, exactly. It's a horizontal compression by a factor of 1/5, right? So horizontal compression by a factor of 1/5. D equals 6. What does that do? It moves it to the right by 6 units, okay? Right by 6 units. And then C equals 7, it moves it up by 7 units, okay? You see this same trend, the rubric is going to be exactly the same. Now, what do I mean by that? Check this out. So this was for an exponential function, right? This was for an exponential function. What if we do this for a cubic function? Look at this. 3 times x minus 4 cubed plus 5. What's our function here? What's the parent function? And it is not an exponential function here. What's the degree of this function? I guess you can also call it
3.
Right. The parent function here is y equals x cubed, okay? This is our parent function. Now just compare them, right? A is 3, f is, well, that just means the function. In this case, it's x cubed. K here doesn't exist. D is going to be 4, and C is going to be 5. So it's a vertical stretch by 3, goes 4 right, 5 up, okay? So this is going to follow the same trend. What we can do is we can introduce a k value, right? Here, so the k value has to be within the cube. So we can make like 6, like that. There we go. Now k value is 6. That's a horizontal compression by a factor of 1/6. Okay?
Okay.
So this the trend for any transformation, maybe eventually when we do sine, cosine, I don't know if we did it, but it's gonna be the exact same thing. This thing is gonna come over and over. You just have to identify the 4 magic letters, A, K, D, C, and the parent function, and you should be good. But then they're gonna ask you to graph this. Now, the trick to graphing this is using something called the point mapping rule. Point mapping rule, which says any point xy from the parent function becomes what? If you remember, there's a little bit of a formula thing going on. It is x over k plus d ay plus c. Okay,
Mm-hmm.
we kind of did this in exponential. This is okay if you don't remember, but eventually you're gonna have to, like for a test or something, you're gonna have to remember this. It's not that hard. So now what does that give us? Well, it's gonna give us the points on this transform functions, and then it's just a matter of plotting it on the grid, right? Now look at this. X over k, well, k is 6, so it's gonna become x over 6 plus, what was d? D was 4. And then you have ay, which is 3y plus 5. That's our formula, right? And
Uh-huh.
then xy from the parent function. Now look at this. Our parent function is x cubed. Y equals x cubed. When the x value is minus 1, what's the y value for this parent function? Well, just plug x as -1, yeah? See, -1, -1, what's -1 cubed? Like,
Just -1.
exactly, -1 is just -1. Now when x is 0, what's the y value? What's 0 cubed?
0.
Right. What about 1? Just a 1, right? There we go.
Mm-hmm.
2 would be 8, right? And then once you have that, the next step would be to plug this x in here. I'm gonna need a calculator for this one. So -1 divided by 6 plus 4. So that's 3.8, right? Like that. Again, the numbers are going to be better here because this is a made up question. -1, 3 times -1 plus 5, it's 2, right? And then you just keep going. This will be 4, 5, 1 over 6. That's going to be 4.28. I'm again plugging this as y in there, and I plug this as x in here. And then the last one, 2 divided by 6 plus 4 is 4.33. And then 3 times 8 plus 5 is 29. Okay, like that. Now finally, you just plot this on the grid. Right, you just plot it on the grid. So our final transform function, again, I'm going to be very, this is not precise, but 3.8 and 2 would be somewhere there. 4 and 5 would be somewhere there. 4.2 and 8 is going to be somewhere there. And then 4.33 and 29 is going to be somewhere there, like that. Usually what we want to do is, because this is a cubic function, right? It's a cubic function. The parent function looks like this. So what I should have done is I should have picked some points here, like -3 or something. Because right now, if you look at this, I only have one part of the graph, right?
Uh-huh.
I'm missing the other half, but that's not a big deal. You can just kind of extrapolate for now. As long as you have 5 points, you're good. But then again, ideally, you want to pick, for a cubic function, you want to pick some points here and then some points up here. Maybe space them out a bit. So you have, it's easier to connect the dots. Okay?
Okay.
So again, this is transformations. Every transformation, if we do some other ones, it's going to be the same exact thing. You're going to compare with this main guy, this rubric. You're going to identify A, K, D, C, point mapping rule from the parent function, and you're done.
Mm-hmm.
All right, let's check out what they've gotten for us. We won't spend too much time on this. It says describe the transformations that was applied to y equals x cubed, and then graph this function. Alrighty, step one. Again, this is a trick question because if you go to compare this with this guy, a f k x minus d plus c, notice the k is not in a bracket. 1 over 2 is your k value, right? But it's not in the right order. The parent function is x cubed. Even if they didn't give us, we could have seen that the parent function is x cubed. So what you need to do is pull out the 1 over 2, right? Here's a question for you. If you pull out that 1 over 2, it's going to be a little bit tricky. What are you left with in the bracket here? You see this 1 over 2? We're going to take it out from the x and from the 1. Think of it this way, right? Think of it this way. 2x minus 6. If I pull out a 2, what am I left with in this bracket?
4 and an x.
Nope. It's going to be x minus 3. Okay? When we're pulling something out, you can just divide them individually. 2x over 2. Pulling out means division. 2x over 2 cancels out, so the 2x becomes an x. Then you have negative 6. You're pulling out a 2. You're left with negative 3.
Okay.
Okay, pull out means you're just plucking it out. Now think about it. 1 over 2x plus 1. We're plucking out the 1 over 2. What am I left with? So 1 over 2x over 1 over 2. The 1 over 2 is canceled out. You're just left with an x. What about the other one? If you pluck out 1 over 2 from 1, what are you left with?
Like 0.5.
So you're doing 1 over 2, right? Like that? So that'll be 2. You're plucking out 1 over 2 from a 1, it's 1 over 2. It's gonna give you 2. Okay, 1
Okay.
divided by 1 over 2 is 1 times 2 over 1, that's a 2. So x plus 2, there we go. X plus 2, and now it's in the right form, alrighty? Now it's in the right form. Now tell me what a, k, d, and c are. I'll just compare this one with this one.
Um,
What is a? Right, we're trying to find what a, k, d, and c are.
a is negative 8.
Right, what about k?
1 over 2.
Right, what about d?
D is 2.
D is minus 2. Right, because it already comes with a negative sign there. D is minus 2. What about c?
Negative 3.
Exactly. And now it's asking you to describe the transformation, so we need to kind of say this in words, right? What does a equals negative 8 do?
It's a compression.
It is not a compression. It's a reflection on the x-axis because of the negative sign, okay? So it's a reflection on the x-axis, and then the 8 is a vertical stretch. It would have been a compression if it was like 1 over 2 or something, or minus 1 over 2. Okay? You see this number? Ignore the negative sign. If that number is greater than 1, then it's going to be a stretch, but it's the opposite for the k value. So for a equals negative 8, it's a reflection on the x-axis, so it flips upside down, and it's a vertical stretch by a factor of 8. What about k equals to 1 over 2? What does that do?
Um,
It's horizontal, right? First of all, it's horizontal. It could either be a stretch or a compression.
is it a compression?
It is a stretch. For the k, it's flipped.
Okay.
So it's a horizontal stretch by a factor of 2. It's 2.
Mm-hmm.
What about d equals -2? What does that do?
Um,
D equals -2, left or right? So D and K, right? D and K are horizontal. So D can either go left or right only. Does it go left or right?
left,
Yeah, exactly. Left by 2. What about C? C goes up or down?
down.
Down, exactly. And there you go. That's the first part of the question, right? Down by 3 units. That's all there is to it. You just have to rewrite it in the correct form. And the only thing you have to do is sometimes, like in this question, you have to take out the K value. And it's just a comparison, right? Well, what are the 4 letters? And then they kind of give you what the transformations are. Part B is
Mm-hmm.
asking us to graph it. So to graph it, we're going to use the point mapping rule. X over K plus D, AY plus C. So, all right, here's a question for you. What is X over 1 over 2? What does that simplify to?
Um,
Think of it this way. X over 1 over 2 is the same thing as X divided by 1 over 2. What do we do when there's a division sign?
you multiply.
Yeah, you multiply and then you flip the latter term, right? The second term like that. What's X times 2 over 1? Oh, the
2.
1, yeah, exactly. The 1 you can ignore. This is going to be 2x.
Mm-hmm.
So it's going to be 2x, and then d is minus 2, and then ay, so it's -8y minus 3. Okay?
Mm-hmm.
And then we have x and y, and this x and y comes from the parent function x cubed. Y equals x cubed. Okay, now tell me, when x is -2, what's the y value?
It's -8.
Right. What about 0?
It's 0.
Right. What about 2?
+8.
Right. Let's go one more. 3 would be 27. 3 cubed is 27, okay?
Mm-hmm.
And now last part, we're just going to plug this as x in there. So 2 times -2 is -4 minus 2, -6. Well, this is going to be a huge number. -8 times -8 is +64 minus 3 is 61. Right? I can just kind of do this in my head. 2 times 2 is 4 minus 2, 2. -8 times is -64, -67. 3 times 2 is 6 minus 2 is a 4. -8 times this is going to be a huge number. It's going to be like -300 something, I think. Doesn't matter. And there we go. Those are our points, okay?
Mm-hmm.
So now we just kind of sketch it and join the dots. Yay. Again, this one you don't have to be super precise because the numbers are so big. So -6 I'm going to say is there. It's -61. Let's say it's there. That's our first point. Next one is a -2 and -3 is going to be right there. -2 and -3 is going to be maybe right there. 2 and -67. 2 is going to be there. -67 is going to be all the way down there. And then 4 and 300. So 4 and 300 something is going to be right there. And there we go. There is our sketch. You just kind of join the dots. All right.
Uh-huh.
So there's how you can kind of like graph these kind of functions. Okay. It's a
Mm-hmm.
little bit tricky, right? It's a little bit tricky, but the idea is the same. AKDC. AKDC. Yeah, see, they're using the same thing, AKDC. I don't know why they made so many tables. So, wouldn't really do it this way, but it's okay. So they used multiple tables. Well, what we can do is they're using the point mapping rule, but they're using one transformation at a time. Like here, they're only using A and K, I guess. And the next one they use D and C. But you can do them in one shot, okay, in one step. Let's look at the next question here. Determine the x-intercepts of this function. What's special about the x-intercept? What's special about this x-intercept? Something, what happens at the x-intercept if you think about it?
Y is 0.
Yeah, exactly. So we're just gonna say 0. Okay, so how do we solve this equation for x? That's all there is. It is a quartic equation. Quartic means degree 4.
You add 48.
Yeah, that's good. You add 48. So 48 equals 3, x plus 6 to the power of 4. What now?
You divide by 3.
So 16 equals x plus 6 divided by, to the power of 4, sorry. Now, we need to get rid of that power 4.
You find the fourth root of 16.
Right, now this is going to be the question. Right? What's the fourth root of 16? So we're trying to find this, right? Fourth root of 16, which is the same thing as 16 to the power of what?
1 over 4.
Yeah, exactly. What's 16 to the power of 1 over 4? You can use a calculator.
It's just 4.
No, it's going to be, if you type this in a calculator, it's actually 2. The fourth root of
Oh.
16 is a 2, right? What does fourth root mean? You're looking for a number. When you multiply them like itself 4 times, you get 16. Okay? So it's 2, because 2 times 2, 4 times 2, 8 times 2, 16. But now here's an issue, and I don't know if we have ever talked about this. Let's use an easier example. What is the square root of 4?
2.
Right. But what if I told you there are 2 different answers to this? 2 is one of them. There's another one. It is negative.
-2.
Exactly, because -2 times -2 is also 4, right? 2 times 2 is a 4. -2 times -2 is also a 4. So whenever you're taking these even roots, right? By even root, I mean the square root, the fourth root, the sixth root, the eighth root, like even numbered root, what you need to do is you need to add a plus and minus. There's going to be 2 different solutions. 16 to the power of 1 over 4 is, there's 2, but it's also minus 2. Square root of 4 is 2, but it's also minus 2. It's usually denoted like this, denoted like square root of 4 is plus minus 2. Okay, So we know the square root of 16, using same ideas, it's plus and minus 2. And now we've gotten rid of the fourth power, like that, okay?
Uh-huh.
So what does this mean? This means either the positive 2 is equals to x plus 6, or it means the negative 2 equals x plus 6. And then you want to subtract 6 from both sides. So x is going to be 2 minus 6, negative 4. That is one of the x-intercepts. And the other one is going to be x equals negative 2 minus 6, x equals negative 8. Oh, there you go. It has two different x-intercepts. Okay?
Okay.
So yeah, see, let's look at the way they did it, which is very similar to what we did. The square of 16 is plus and minus 2, which means either 2 equals x plus 6, and then the minus sign becomes and minus 2 equals x plus 6. Here's a question for you. What is the cube root? What is the cube root of negative 27? I'll give you a hint. 3 cubed is 27. You can plug this in a calculator if you want. Negative 27 to the power of 1 over 3.
I got -9.
All right, so this is how you'd put this in a calculator. Negative 27 to the power of, put 1 divided by 3 in a bracket.
-3.
A question to you, is it going to be plus minus 3 or simply negative 3?
Just -3.
Exactly right. It's only going to be plus minus if it's an even number through, right? Here's another question. This is a trick question. What is the fourth root of negative 16? This is a trick question. The answer doesn't exist. There is no answer, okay? So because you're looking for a number, when you multiply it 4 times, you get negative 16, yeah? The same number, the same number. So if you pick negative 2, if you multiply it 4 times, you're going to get positive 16. If you pick positive 2, you're also going to get positive 16. So if you have a negative, you can't take an even root, okay? An even root, like the square root, fourth root of a negative number. Okay? Like, what's the square root of negative 4? Well, it doesn't exist. It does exist. It's 2i, but that's for another time. That's not the real number system. We won't be getting into that anytime soon. That's gonna be in university maybe. So if there's a negative number, can't take the square root. But then if it's a eventh root, right, like maybe the fourth root of 64, it's gonna have two answers. One of them is gonna be positive, the other one's gonna be negative.
Okay.
Okay, here it says match the function with its most likely graph. And explain how you got to that conclusion. Let's look at this graph. Is this an even degree or an odd degree? Polynomial.
It's even.
Right, so is it C or D? But C and D are the only even ones.
Um,
Is it positive or negative? Just look at the leading coefficient, right? It's between C and D.
C.
Yeah, it has to be C, right? It has to be C. So this one is C. Let's look at this graph. What's the degree?
Um,
It is
two.
it's an odd degree. No, it can't be two. Two means it goes, two would be quadratic, right? It goes in the same direction where it came from.
Uh-huh.
Two would be the end behaviors are the same. Two would be, no, this one's a three, right? It's a cubic function. The parent function looks like this. But then again, this one's moved up a little bit and to the right a little bit, yeah? B is a degree 3 polynomial, okay? Degree 3. So degree 3 means it's between A and B. Is it A or B?
It's A.
It has to be A, right? Because it's not flipped, and that's easy as that one. C must be B because this one's odd degree, right? That means D must be D. Negative degree 4, okay? Negative degree 4.
Uh-huh.
Here it says state the parent function and describe the transformations. Look at A. What's the parent function? What is the parent function for A?
X to the power of 4.
Yeah, exactly. So what is our A and what is our C here? K is 1. K doesn't exist. D doesn't exist either. A would be the first number 5 over 4, right? For A,
Uh-huh.
A is 5 over 4 and C is 3. And see, A is bigger than 1. 5 over 4 is like 1.25 or something. So that's a vertical stretch by a factor of 5 over 4. What does C equals 3 do? Left, right, up, down.
Up.
Up by 3, exactly. That's all there is. B, what's the parent function for B?
Just X.
Just X, right? So what are the transformations? It's a vertical stretch by 3, the slope, and a shift down by 4, right? That's all there is. For C, the parent function is x cubed. But now be careful. What is AKDC for question number C?
A is 1.
Yeah, good. A is 1.
Is K 3.
K is 3, that's right. A and K is the easiest to identify. D is the hardest to identify.
Negative 4.
D is negative 4. Good try, but no, it's not. Because you need to pull the K out, right? You need to pull the K out like this. Okay? If you pull 3 out of 4, what do you get?
1.
It's a division, it's not a subtraction. Like think of it this way, 3x plus 9, right? If you pluck out a 3, you're left with x plus 3, okay? What did we do? We did 9 over 3. Same idea, 3x plus 4. If we pluck out a 3, what are we left with? It's not 1, nor is it 4. Need to divide.
0.75.
No, it's going to be 1.333 because you're doing 4 over 3. You can just leave that as a fraction, right? What did we do here? We did 9 over 3. Okay?
Okay.
When you pluck out a 3 from a 4, it means you're dividing. What's 4 over 3? Well, it's just 4 over 3. There we go. So what's D actually?
Um, 4.
D would be negative 4 over 3. D is this guy.
Oh, okay.
Okay? D is negative 4 over 3, and C is minus 7. Well, A and K, if they're 1, they don't do anything. You don't even have to mention them. K is 3. What does it do in terms of transformation?
Um, it's a reflection.
It's a reflection? No, it's not. Reflection would be if K was negative. If A or K were negative, then it's a reflection. Like if K was negative 3, it would be a reflection on the y-axis. But there's no negative sign with the attached to the K, so no, there's no reflection in this question, not for C anyways. K being 3 is a horizontal compression by a factor of 1/3.
How do you know if it's a compression or a stretch?
So it's the opposite for A and K, right? So look at this. If it was 2 and then 3x plus 3, whatever, doesn't really matter there. A is 2. A is as you see it. A doesn't deceive you. A is as you see it. A is 2, that's a number that's bigger than 1. So this is a vertical stretch by a factor of 2. But K is the opposite. So K is 3. You would expect it to be a stretch, but it's actually a compression by 1/3. Okay, another way to think about this, someone told me once upon a time, is that X lies. I don't know if that makes any sense. X lies means the number that's attached with the X, this number, you'd expect it to be a stretch, but it's actually a compression. Okay,
Okay.
so that is a horizontal compression. What does D minus 4 over 3 do? Well, it goes to the left by minus 4 over 3. C negative 7. Left, right, up, down.
Down.
Down 7 units, exactly. Having fun?
Sure.
Right, I can tell. A, K, D, C. We're doing it for this question, D. What is A, K, D, C?
A is 1.
Yeah, A is not 1. Good try. A is negative 1, though.
Negative.
Yeah, what's K?
K is also 1.
K is also 1. K is 1, does absolutely nothing. Ignore it. What is D?
D is -8.
Yeah. What about C?
Is it 1?
C is 0, right? You're adding a 0 on
Okay.
this side. Only A and K are 1s. D and C, if they don't exist, it's a 0. So now tell me, what does A equals negative 1? What does that do in terms of the transformation?
Um, it's a vertical stretch and a reflection.
All right, there's no vertical stretch. It's only a reflection on the x-axis. It would be a
Okay.
vertical stretch if it was negative 2. Negative 2 means there's a reflection on the x-axis and vertical stretch by 2, right? If it's A is negative 1 over 2, that means it's a reflection on the x-axis, and then there's a vertical compression by a factor of 1 over 2. But in this case, if A and K is 1, there's no stretches or compressions. That one is simply a reflection on the x-axis. reflection on the x, d -8 means it goes left 8. Okay, C0 you can ignore as well. There we go. What's the parent function for E? What's the degree of that polynomial?
2.
Yeah, good, it's 2. For F, I just need you to tell me what the D value is. For F, simply tell me what the D value is. Because everything else is pretty obvious.
Is it -7?
It is not -7. It's not obvious. You're gonna have to do some. You're gonna have to take a little bit of dividing. Think about it this way, right? 1/5. We need to take the 1/5. You see, it's not in a bracket inside. You need to always take out the 1/5. So what are we left with in this bracket? If you take out 1/5 from 1/5x, again, you're just dividing. We're taking out 1/5 from 1/5x. The 1/5 cancel out. You're just left with an x. Okay? Plus, now we're going to take out 1/5 from 7. 7 over 1/5. What's 7 divided by 1/5? You can do this by hand if you want. You can also do
This
this.
is 35.
Exactly. So in this bracket, you have x plus 35 once you take out the k value. So what does that mean for the d value? What is it actually? It's not -7.
It's -35.
Exactly, it's -35. There's a horizontal shift, or it goes to the left by 35 units. Okay?
Yeah.
That's the only one you have to be kind of careful for, because everything else is pretty obvious. A is 2, K is 1/5, C is -4. It's the D value that's always going to be the hardest. So you just got to take some things out. What are these questions? What do they want? Okay, all right, this is going to be a little bit tricky as well. So what they've given us is, now we're going to have to work backwards. Before we had an equation, but now they've given us the actual transformations, okay? And now maybe we have to come up with the equation and use the point mapping rule. It's not that bad. So again, it's the AKDC magic. But instead of reading this from an equation, we have to read it from the words. It says vertically compressed by a factor of 1/2. So which letter does that represent?
A.
A is 1/2. Horizontally compressed by a factor of 1/5.
That's K.
So K is 1/5.
Yes.
K is 5, because K lies, remember. K is the one that's opposite. K5 means, in terms of its transformation, it's a compression. What's D? Horizontally translated 6 units to the left.
It's -6.
Yeah, D is -6 and C doesn't exist here. And you remember your point mapping rule, X over K plus D, AY plus C, right? So it's going to become X over 5, well, D is 6, and then AY 1/2Y, well, there's no C value, there we go. So that is our point mapping rule, okay? And what they've asked us is, they've given us a couple of these points from the parent function, and we need to find out what these points became after the transformation. Very simple. You just plug -1 in there. Just plug -1 in there and plug -1 in there. So -1 times 1/2 is -1/2. -1/5 minus 6 is what? -6.2 or something close to that.
Okay.
2/5 is 0.4 minus 6 is -5.6. And this will be 4. And there you go. That's how you do this question.
Mm-hmm.
Okay, so sometimes they'll give you the actual transformations and you're going to have to work backwards. Let's do 1 or 2 more of these. Okay, let's do E. Just tell me what AKDC are.
A is
The answer for A is right here. Reflected in the
K
x-axis.
-1?
Yeah, that's all there is. A is -1. What is K?
Is it also -1?
That is correct. What is D? D is the horizontal shift. Yeah, left or right.
Okay.
D is 0.
Oh, C is 9/10?
Yeah, C is. How
Okay.
do we know C is 9/10? Vertical means what? Or it says up here, yeah? C is up, down.
Uh-huh.
D is left, right. So up means C is positive 9/10.
Mm-hmm.
For F, what is A, K, D, and C?
K is 7.
Now, again, remember, K is flip-flop, flippity. If K is 7, that's a horizontal compression by a factor of 1/7. Hey, look at this. This is very weird, right? If K is 1/2, this means it's a horizontal stretch by a factor of 2. If K is 3, that's a horizontal compression by a factor of 1/3. K is opposite. So the fact that it says a horizontal stretch by a factor of 7 means K is 1/7.
Oh, okay.
Because K is flip. K lies, okay? That's a deceiving one. What else do we know here?
C is -2.
That's right. C is -2.
D is -4.
Yes. What is A?
1.
1, exactly. Now, if they ask you to write an equation for this, look at this. We know it's an x cubed. It says somewhere up there. A, bracket open, K value, bracket open, x plus 4 cubed minus 2. There we go. That's the equation. It's a plus 4 in here because we know D is minus 4, right? Okay.
Uh-huh.
So that's how we get from transformations to the letters to the equation, working backwards. Let's just do maybe 1 or 2 of these. It says find the x-intercept. It only says find the x-intercepts. Let's look at C. I mean, idea is the same, right? How do you find the x-intercepts?
You set y to 0.
Yeah, you set y to 0. All right, what's next? What do we do here? Step 1.
You subtract 48.
Right, and then
You divide by -3.
what's negative 48 over negative 3?
Is it positive 16?
It is. Now what do? We have x plus 1 to the power of 4 equals positive 16.
You find the fourth root,
Right.
which is 2.
One of them is 2. Fourth root means it's an even root. Yeah, there's going to be 2 solutions.
2 and -2.
Exactly. So either you have 2 is equals to x plus 1, or you have -2 equals x plus 1, right? Subtract 1 from both sides. X is either 1 from this one, or x is -3 for the other one, and you're done. All right, f. Again, idea is the same, right? We first put a 0 here. What do we do next?
You add 20.
Yeah, you add 20. So you get positive 20 is equals to negative all of that. What is next?
You find the cube root.
So first you want to get rid of the negative sign, right? When you're trying to solve an equation, we follow this, okay? You see there's a
So
negative,
find -20.
-20. First you do -20, and then you want to deal with the exponent. What's the cube root of -20? Gonna have to use a calculator for this one. It's not gonna be a nice number. It's gonna be a lot of decimals, but it's okay.
How do I plug it into my calculator?
-20 to the power of 1 divided by 3.
-2.71.
Yeah, there we go. So we have -2.71. Would it be positive at -2.1 or just the negative?
Just the negative.
Just the negative, that is right, because it's only for eventh root, okay? Like 4th root of 16 is plus minus. Only when this guy is even. So now it's just a simple linear equation. How do we solve this for x?
You subtract 5 and then you divide by 2.
Exactly, so -2.71 minus 5 divided by 2. So that gives me 1 or 2 decimal places. X is -3.86, and you are done. Okay,
Uh-huh.
easy as that. Nothing fancy going on there. What do you think about transformations?
It's not too bad.
It's not too bad. Here, let's do something which is gonna be which is gonna appear to be pretty mundane, but we're gonna use this idea tomorrow. And the idea is, like, so far what they've given us nice numbers, but what they will eventually give you is something like this. They're gonna be like, what are the x-intercepts of this? And then you make the y 0 and you kind of hit a brick wall here. Because you can subtract 6, yeah, that's fine. But then what do you do next? There's nothing you can do. To solve a question like this is going to be our next goal. We need to do something called polynomial division, which is a pretty interesting topic. But here's how it works. It's very similar to normal division. let's say our divisor is 2. We're trying to divide, I don't know, some random number, 338. Actually, let's make this a little bit more complicated. 3119. All right. Do you remember how to do long division?
I guess.
Look at this. You got to look at this digit, right? This, is
Uh-huh.
this bigger than 2? Yeah, 2 goes into 3, right? If it didn't go into it, then we need to consider 2 digits here. But 2 does go into 3 once. 2 times 1 is 2, and then you subtract, right? Which is called the remainder. 3 minus 2 is a 1, yeah? And when you
Mm-hmm.
subtract, you get to bring the next digit down. 11. How many times does 2 go into 11?
5 times.
Exactly, 5. 2 times 5 is 10, and you're left with a remainder of 1. And again, you're allowed to bring the next guy down. 2 times 9 is 18, right?
Mm-hmm.
And there we go. This thing on the outside, this is called divisor, the guy you're dividing by. This thing up top, what is this called? It has a name. It's called the quotient, okay?
Mm-hmm.
Down here, this is your final remainder. And we're going to use this idea to break up a big polynomial like the one we saw before. You have to break it down into smaller pieces. Only then can you find the x-intercept. So it's just basically the main villain of this entire unit. The main goal, I guess, is to find x-intercepts of things that are not in factored form, which we will, I guess, get into tomorrow. Cool?
Okay.
All right, I'll see you tomorrow then.
All right. Thank you.
Bye-bye.